Hello, and welcome to this Automation World webinar on achieving production agility and right first-time quality, sponsored by GE Digital. I'm David Greenfield, Director of Content for Automation World, and I'll be moderating this webinar. Now, for this webinar, I'm joined today by Joe Gerstel, Director of Digital Product Management at GE Digital. Now, in Joe's presentation today, you'll learn how to use digital technologies to empower your workforce, reduce variability, and increase efficiency, all based on real-world examples from major manufacturers. Now, Joe will also explain what to look for when choosing a manufacturing execution system that can span mixed manufacturing environments. Now, at the end of the presentation, we will have a question and answer session, so feel free to enter your questions for Joe at any point during the webinar. And with that, I will turn the presentation over to Joe.
Okay, thanks, David, very much for that introduction. Appreciate it. So yeah, my name is Joe Gerstel. I'm Director of Product Management for our MES solutions at GE Digital, and I'm going to walk you through agility, talking about agility, production agility, as well as right first time quality. So I'm excited to be here today and talk with you about this. So from GE Digital, just a quick overview of what we do. We're all about putting industrial data to work. We're all about taking the data that our customers produce, either in their factories or out in the field, and putting it to work and solving the toughest challenges out there with that. So we're really involved in our customers' business and how they operate. So we have a lot of background in that area. Well, it all starts with data. So it all starts with really how much data you can attract, but it's not necessarily about how much data you can store and consume, but it's also about how to use that data. If you think of this diagram like a pipeline, where the data comes in at the left-hand side and it ends up coming out at the right-hand side, there's a lot of leaks in the pipeline, right? So even starting from the data capture, we don't all capture enough the data that is available on our floor. Sometimes we want to capture that data, but it's just not feasible, right? Either because we don't have the equipment, the sensor equipment, we don't have the training for the operators, we don't have those types of things in place to capture that kind of data. And along with that is even infrastructure and data management, where if we don't have the right types of software and the right types of even hardware to a degree in place, and the ability to really understand where that data is going, think about like a time series types of data coming in at very, very high speed. You need to be able to track that data. You need to have the space needed to do that, and you need to have the network and bandwidth available to capture the kind of data in real time that sometimes you need to make those decisions. Then there's the ability to use that data for analytics and applying things like PCA, or which is of course primary principal component analysis, or something else like that in terms of analytics. As you move forward into visualization, there really is a lot of data missing all throughout that process, and really unable to, without the ability to capture that data, it can be hard to be agile and to meet right first time quality. So let's talk about how we might address that, from a software perspective, and how we could help alleviate that problem in terms of applying a solution to it. So, in terms of production agility, how agile you can be really is all about, you have to know what's happening. It goes back to that data, right? You have to understand your situation. You have to understand what position you're in, and really, it's hard to solve a problem when you don't know where to start. You don't really understand the problem fully. So one of these things that we see sometimes causing problems, especially prior to COVID, but even during COVID, right, is this fast changeover and short runs, maybe of different size products, right? Maybe a 4-pack up to an 18-pack or something of a particular product. But it all comes down to, how do we do those fast changeovers? What software can help us? What procedures, what standard operating procedures can we put in place? And how can we put them in place in such a way that is operational and mechanical, that we actually can track that those procedures are being performed, and followed by the operators on the shop floor. How do we do, when you have changeovers, when you're moving from one product to another, it's important to minimize that waste. And systems like the MES systems and other systems, time series data even, can help you minimize that waste. And of course, the ability to adjust your schedule on the fly in real time. We all know that the schedule comes down from the ERP, and we all know that it's immediately out of date as soon as it hits the shop floor. So it's just real world, real life starts to happen, and it affects that schedule. With all of this, you need to be able to react in real time. You need to be able to understand what to do at the right time in real time. So how do you do that? And what are the things that you can do to understand, better what's happening in your plant and really being able to adjust in real time? Well, it comes down to tracking metrics that really are important, that really matter in your environment, in your world. A common metric that people use is overall equipment effectiveness, or OEE. Another one very similar is total effective equipment performance. Process reliability is really about understanding the processes that you use and tracking in terms of the data to understand whether those processes are actually being used properly and actually are reliable enough to trust. And then of course, understanding your people, your equipment, who's on, what equipment is up and running, what equipment is under maintenance, what orders are coming down onto what equipment, and then the common systems and processes that actually track the types of things that are happening. So the ability to really track these kind of things in real time allows you to have that production agility that we've talked about. And once you understand these numbers and you have a grasp for what's happening, it's oftentimes we have this concept of a hidden factory. Turns out that, an example I'll show you later, customers able to find 9% more efficiency in their process as they made their products. That's a huge number. And it depends on the size of your plant, but that could actually be an entire line in a situation. Really the kind of effectiveness and efficiency that you can find really lets you reduce or stay at the same capacity while producing more product at the same time. All of this comes back to you have to have the right culture. You have to have a culture of openness and learning and the ability to see opportunities and people that want to make a difference. So it's a big factor in it, and having the right systems in place can actually help that happen, right? And giving the operators the tools they need can help them be more involved and engaged in what they're doing. For example, right, in today's modern day, everybody understands how to use a mobile device, right? They have them in their pockets, they walk around with them, and they're starting to expect that they have those types of things in the shop floor. And with the kind of systems that you can put in place, you can give these tools to the customers or to the users, and they can engage with the system in using a tool that they're very familiar with and easy to understand and use. So it's great to have the data, and capturing all the data is one thing. If you remember back to our leaking pipe example, a lot of capturing all that data is fantastic, but if you can't analyze or to use it, it's not very useful, right? So getting that information to the right people at the right time is critical. So when we talk about visualization of that data, we want to provide that data to the right people. So an operator needs to see needs to see what's happening on his machine right now in real time. A supervisor perhaps wants to look at over the shift, right, of what's been happening and what are the trends that he can identify and address as he's going about his business for that day and driving the orders through the system. It's really, again, about getting that data to the people that need it in ways that they can actually use it, right? A piece of paper is, valuable, but it's not as valuable as a real-time visualization tool page on a mobile device or on a desktop or laptop, for that matter. Another example of that is, right, the paper can be misleading because you don't always have that ability to see the single source of truth, the ability to see all the data from one place, whether you're an operator all the way up to the plant manager. The ability to go to one system and trust that that data is accurate and that you're able to make decisions from it without compromise. And then again, we've talked about this a little bit before, but it's not only about the fact that the operator gets to use a mobile device that they're used to, but it really increases efficiency. We have one customer that they're starting to roll out mobile devices, and at 2 of their plants, that's all that they use. They use strictly mobile devices. The operator can walk around from one end of the line to the other end of the line with his mobile device and understand what's happening and be able to enter data as they go along, drill in to understand trends or various data coming off the equipment. And really all this lines up with really giving you a view at the highest level of your environment. And with those mobile devices and with the data as a single source of the truth, it really increases the ability to collaborate, right? So now the operator is seeing the same data that the supervisor is when the supervisor is in the control room, but they're all looking at the same thing. It's just not possible with a piece of paper or point solutions for that matter, right? Where you have a bunch of solutions that solve one specific problem, but they don't talk to each other. It's very hard to get that single source of truth, and therefore it's hard to collaborate, right, between the various folks using the systems and the data. All right, so we've talked about agility, and we've talked about how you can improve your ability to drive that agility throughout your organization. And really it comes down to, again, that a lot of it comes down to the data that you're capturing. Well, some of that data is about quality. So what do you do? You know, it's great to have the agility to make changes on the fly, but if you're producing bad product, that's not very helpful, right? Now you're just making bad product faster. You know, how do you address the quality in real time and with a kind of standard process? In our case, GE, we're very familiar with the lean process, Six Sigma. And how do you drive that first time quality properly? And we have a concept of lean, very simple: identify the issue, plan to make a change to it, execute the plan, review it, and continue that cycle. Just continue to improve over time based on that cycle. So what are really the kind of the 5 pillars of the quality and right first time? Well, we talked about this already. Data collection. We have to be able to collect the right data at the right time from the right place through the right person or through the equipment, which is even better, right? So automating your machinery, which most of the time in this day and age, you already have that automation. And for those machines that don't have the automation, maybe they're older machines, it's much easier than it used to be to put automation and sensors on that equipment to gather different types of data that can help you making the right decisions and making better quality product. So there's, of course, other systems that exist out there that you can gather data from, right? Obviously, gathering data from the LIMS system, understanding your laboratory data that's coming in and capturing that data is essential to understanding your quality. And then, of course, understanding what it costs in terms of quality, whether you should be focused on a particular product that is a high value product versus, you know, do you know what the value is of the product that you're about to run, and whether it's worth making a certain change to decrease waste on one product while at the same time, unfortunately, increasing waste on the other product. Maybe that's the right decision to do. But without the ERP data, without that financial and production information, it's hard to know that. Then it's great to have all this data, right? But you can have a bucket full of data or a room full of data, but unless it's put in context, it really isn't all that helpful, right? You have to be able to relate that data. It's not just about the context, right? It's about, well, in the end, it's about relating the data to each other, right? So starting with standards such as S95, S88, for your plant model, for your production, execution, and then being able to map that data to the equipment. But then taking a step further, right, and mapping, okay, what product am I running right now? What is the family of the product? What is the particular event that I just created, or the batch, if you're in that type of environment. So relating all that data together and providing that context gives you the ability to make decisions that you simply couldn't make without it, right? Just gathering a bunch of data doesn't do the trick. You have to apply the type of context, especially when you talk about time series data, right? Time series data, you can generate boatloads of it, but unless you understand what is happening at the time that you collected that data, the data can be a little confusing and actually sometimes make it worse. So contextualization is really key to understanding what's going on. Okay, so now you have the data, you have the context, you understand what's happening at what time and how they're all related to each other. Now you can start to do deep analysis and apply analytics to it and monitor your quality in real time. So something simple like center lining, right? Without the context, without that data, it's impossible to do center lining and to know whether you're within the range of a particular variable that it should be, right? How do you do maintenance? How do you plan appropriately when let's say you're having a lot of downtime on a particular product? Unless you know that context and have that data, it's hard to do condition-based alerts, right? And how do you do SPC without the context? So this is the kind of thing that you can start to really get value out of very, very quickly. Again, the ability to apply simple things, simple analytics like SPC, where your say 3 points out of 5 are above warning, so you know you might be coming into a problem. That's really helpful to know. Now you can get into deep stuff like artificial intelligence and machine learning, which are some of the things that we're working on at GE Digital, and the ability to let the system tell you what's happening and why it's happening, and start to do things like one analytic that we're working on, we're trying to predict the downtime reason based on various variables into that equation to understand really what the downtime reasons are. Sometimes the machine can tell you that. Sometimes the operator can tell you that. But oftentimes the operator is very busy doing something else when there's a downtime, right? So they don't always come back and fill those in. Well, through this work that we're doing today, we hope we can predict that kind of downtime information, and that's just one small example of the kinds of things you can do. We're working in other areas, including waste and various other information across the system, and digging into that data to provide valuable analytics against it. Now, what about taking data from across sites, right? Wouldn't that be great if you could take data from one site that is making the same product and compare it to another site that's making that product as well? Today, it can be challenging, right? You have different systems at the different plants. You have different ways to track data. It's not normalized, right? So it's not in a form that it's easy to track, and there's a lot of data cleansing that has to happen in order to do that. Whereas when you have a system such as an MES system, and you can track that data consistently across your sites, and then bring it up to the cloud, where in the case of GE Digital, we have a hybrid cloud manufacturing execution system where you can bring that data up to the cloud and provide that data in a format that's much, much easier to view across your organization. There's no work involved when you want to compare line A at plant 2 to line B at plant 7. It's very easy to do that because the data is all in one place and it's normalized, which makes it really easy to do things like ad hoc reporting, for example. You don't have to be an expert in the real-time system or database that stores that data. You just have to understand what a downtime is, and we provide that data to you in a fashion that has all the details with it. You don't have to know where to go get those details. It's all put together as metrics or factors associated with that data. Now that's great when you have the data and the analytics, but you have to see it. You have to be able to view those analytics, especially in real time if you're trying to make these right first time decisions, right? And trying to make these agility decisions. The ability to see that data as it happens and as it's occurring when problems are taking place is critical because it allows you to get your attention on that immediately instead of after the fact. The sooner you find out you have a problem, obviously the better quality product you can make. So the ability to visualize that product in that data, I should say, in terms of the context that it was taken into, and really being able to build displays that operators can make decisions on their own, right? Instead of waiting for a supervisor or having somebody else make that decision, they can see that data and be trained to take fast action based on the information that they see. And then the ability to really take that information that you've learned and drive it back into the system and close the loop, as it were, and understanding, hey, when this happens, when I'm running this product and it's this particular crew and it's the product B was run right before this product, I tend to have this kind of problem. Now I can make decisions. Maybe I should run product C after product B before I run product A, right? So yeah, a simple example, right, when you're making beverages, right? Everybody knows this already, but if you're gonna make a darker beverage, you wanna make all your lighter beverages first, right? So the seltzer waters and that sort of thing, you wanna make those first before you start making, say, the root beer or the cola or whatever it is you're making. That's just a simple example. Everybody knows that one, but there are all kinds of little nuances about your products that you may not have the ability to see, but once you do, when you go through these pillars, you have the ability to actually take that data and replay it back in your system and make decisions and let the system make some decisions for you, or train your operators to identify things based on the visualization you provide to them. So really, really critical things that need to take place to make right the first time a standard in your environment. So the ability to understand your quality is one thing, but also to understand the compliance with regulations and to be able to trace all the raw materials that went into your product, all the way from the intermediate materials into all the way into the packaging, and the ability to have that traceability, understanding what raw materials went into a particular product, and being able to put holds on certain product based on the information that you've found as early as possible. So minimizing your impact of, say, a quarantine, for example. The ability to have that the traceability that can be provided by an MES system is really important to minimizing your losses when things aren't right the first time, right? So how do you do this? Well, you have to really, we already talked about this, you have to have the ability to collect that data and store it. You have to have some sort of structured model. This goes back to that context, right? What product am I making? What kind of product is it? What's the batch name? What's the process order that I'm running right now? And how are all those related? And then what's the raw material that started? What process order did it start being consumed in? What process order did it end up being consumed in? And what are all the batches in between that I need to put on quarantine to check and make sure that nothing is wrong with them based on some quality information that we had? The smaller you can make that quarantine, the much better off you are, right? Because you're minimizing the waste that is potential. And driving the folks through proper operating procedures can impact your ability to make quality product, and that end-to-end traceability is critical in that. So, really it comes down to when you want to make quality products, highest quality products, it's about engaging that workforce and empowering them to do their jobs, right? Letting the operator, as I said before, make decisions in real time, right? Training that operator to act like, really, in some cases, sort of a junior process engineer. We have customers that actually do that. They train their operators to go look at data in trends and bring multiple types of contextual data in to look at the data in real time as they're running the machines. So they're not just operators pushing the start and the stop button, but they're actually making decisions based on the visualization and the data that we can give them. Now, the more you can digitize that work process, not just from a matter of collecting the data in a digital fashion, either directly from the equipment or directly from the operator, but also the ability to put their operations in sequence and the activities that they have to perform in sequence in such a way that it makes it easy for them to do their job. So, but we all know that we do things differently. You know, I've been doing this a long time, and I can tell you that every single MES out there has some sort of customization in it. There's just, if somebody tells you it doesn't, then they're not being honest with you. The truth is that everybody has something that is specific to their business. And so with that, you need to have the ability to make customizations for yourself and not hire it out, right? Some cases, maybe it's a massive customization, then of course you want to bring in a partner that knows how to do this really well. But maybe there are situations where it's really just a tweak and it's something that you could do yourself. Having the tools at your disposal to allow you to do that is really important. And then of course we talked about this a lot already, but the ability to put that data, visualize it on any kind of device, whether it's you know, we have some customers that even visualize the data on a watch, an Apple Watch, and they're able to see issues in real time. The watch vibrates on their wrist to tell them that they're going out of warning or out of reject in a particular area, or that an alarm just occurred from an SPC issue, whatever it might be. The ability to have that information on any device you want, including not only from that watch, but up on a big screen up in the factory floor. We've seen it multiple times when you put that big screen up there and it shows all the lines in the same screen. The lines operators start to compete with each other, and it's really interesting to see what happens. And that goes back to that culture that I talked about earlier and how it's important to do that. And it really has to be, and this user experience has to be something that's simple to use, intuitive, just like all the tools we use today on our phones and our tablets and whatnot. And they have to be confident that the data is really accurate, right? I mean, if you have a system that's not providing accurate data, no one's going to use it. They're not going to trust it. They're going to go with their gut instead. And the ability to have this data, again, instead of having point solutions that don't talk to each other, but having this data in one place across your entire organization, a single place to go look for this information and the context all together is really, really important and helps operators and others complete the tasks that they need to do. So what about the procedures, right? I talked again about this earlier, but digitizing the data is one thing. Capturing the data, instead of capturing on a piece of paper, capturing it in a system or on a mobile device is highly preferred over capturing on paper. But what about those procedures? What if you could provide a way to drive the activities of the operator based on their needs, based on the equipment that they're working on? They don't care about anybody else's equipment in the shop floor. They only care about what do they have to do for their equipment. And really taking all that operator knowledge that has been gained over time, right, by these various operators, and digitizing that, and making it such that a new operator can come along and very easily pick up that knowledge because it's already baked into the system, right? So some examples of that, right, are these documentation, work instructions, that the ability to see the work instructions in real time when an issue is occurring, right, is really important. And then driving the operator through those instructions. You know, what do they do at this step? Okay, they do that, check, done. I've performed that, I've completed it. Next task comes up. What do you do with that, right? In the example we have here, we have machine setup. Okay, great, I'm done with that. Now go visually inspect it. Maybe another operator does this. So now you can start to combine activities between multiple people in one place, and et cetera, through the various tasks that need to happen. With all this, you've really kind of filled in that gap, as we say here, of the information. You don't just have sensor data and time series data. You have actual data that says it took Bob, 35 minutes to complete this task. Well, it took Cheryl, 20 minutes to complete this task. Maybe Bob needs some more training. Maybe Cheryl is missing some steps. Now you have the data to go after that and actually address those issues and understand what's happening to help your employees who do want to do a better job, to help them do their jobs better, right? And all this put together especially this last part I talked about with giving accountability and really empowering them, reduces the variability across your organization. And it makes not just the operators more efficient, but everybody more efficient. The schedulers more efficient because they understand how fast this particular crew can run. They understand that there's some maintenance scheduled for a particular piece of equipment in real time because certain factors just happened, and we can make conditional based maintenance a real thing. So when I have 200 downtimes of the same type and I'm running product A, then I know that I need to change the filter because that's usually what happens. And we learned all that through the machine learning techniques that we've applied against all this data that we've been collecting. So really exciting stuff can happen when you have digitized your process and your data. So, we talk about quality management and really, the earlier when we talked about putting people, processes, and technology together, that really goes across the entire value chain, allows you to make some decisions that you couldn't make normally without this data. The ability to have alarming, as I mentioned before, right, as an example, where in this case we see that this particular variable, this basis weight, we're apparently making some sort of paper product here, and this basis weight is above a reject. So we can see at a glance that this has happened a couple of times, actually. We can see that it happened at least 4 times and possibly 5, depends on that little peak on the in the middle of the screen there. And we can see that it does come down, but it does seem to bounce back up. So I have a problem here and I can go after and attack it. So you can do this on not just going above the reject limit, but bouncing around in the warning limit. And again, understanding, so, hey, I'm trending outside of my warning, therefore I might have a problem coming up, and the ability to get that fixed before you go out of reject, while you're still bouncing around in the warning area. Really improves your quality, right? So reduces the waste because you can address an issue much faster and much sooner than if you didn't have this information. So, talking about all this information, all the things we talked about with agility and right first time quality, what I've been inferring and referring to is a manufacturing execution system. That's what MES stands for. And it's really the heartbeat of the plant. It's really what's happening, and it's a pulse of what's happening in the plant and understanding in real time, digitally, what's happening. So, what is going on out there in the world? We hear about this Internet of Things, or sometimes they call it industrial Internet of Things. Well, these are great platforms, right? So you can control your home with some sort of application like Apple Home or whatever it might be, but that platform doesn't run your home. You still have to make decisions on when you want the lights on, when you don't, when you want the furnace to go up and down. The platform doesn't change your environment. It's really the applications that you apply to that platform, right? So simple things like the ability to track specifications and understand when they're out of spec, but also not so simple things that require a little more compute power that can start to identify tighter limits that you could potentially employ based on the information that you've been gathering over time, that the system can actually tell you, hey, you can actually tighten down these specifications. And an IoT platform can't do that for you. You need something on top of it to do that. So really, we talked about digital transformation is a huge trend right now. Everybody's trying to go digital. It's been going on for quite some time, but now we've actually given it a name, and MES is an enabler for that. The ability to transform your business is much more attainable when you have an MES in place. The ability, once you have all this data, capturing data, could be even camera data, right? And capturing images and so forth. Providing that into such a tool like augmented reality or some kind of mixed reality is really powerful. We have a situation where a car manufacturer is able to apply the data that we're collecting in the MES using an augmented reality system to identify and work on defects that are on that on the car that they're product that they're making. Having this continuous improvement cycle, the ability to do continuous improvement really relies on, if you remember, the plan that you have to make when you're doing continuous improvement is really driven by the data that you can capture. And then of course, the outcome, determining if you were successful or not, is also driven by that data. So having that data in a digital format makes it possible to do all that, right? You can capture it on a piece of paper, but it's going to take you a lot longer to make those improvements. They'll be continuous, but it'll be a slow, continuous process. Whereas with digital implementation, you can make it much faster and more efficient. The ability to predict when things are going wrong. You know, the ability to have understanding of what is about to happen based on previous, based on history, based on the fact that you can apply machine learning or AI to the data that you're capturing and actually predict when you're about to go, say, out of reject, or you're about to produce bad product, or whatever it might be. And then bringing that data up, we talked about this, it's great to have that data stored locally. It's great to have all that context, but it can be sometimes challenging if you're not somebody who has access to all that data or understands the relationships well. It can be challenging to go get that data and build your own reports. But if you bring that data up to the cloud and you normalize that data across your entire enterprise, it makes it much easier to understand what's happening in your across your entire organization and take proper steps to make not just a particular plant or a particular line more efficient, but your entire enterprise. And the ability to do that with hosted cloud data is very valuable. Okay, but this is hear this a lot, but MES is hard. Yeah, it is. ERP is hard to implement, harder than MES, but MES is hard too. It's true. So what do you do? What advice, having done this for a long time, let me tell you some recommendations I have. First of all, don't customize initially. You could go build your own system, but it's going to cost you a lot of money and a lot of time to do that. What I suggest is start with something simple out of the box that you can apply in a very short order, right? And apply as much out of the box as you can before you start to customize, right? Now, once you get comfortable, once you make some inroads and make some headway, then great, start to apply some customizations and really take advantage of all that data that you're capturing and use the tools that either the MES or a third party provides to do that. Another one is, remember, we talked about culture. We have mentioned culture a number of times in this talk. It's really important to get buy-in from the stakeholders. Now, I'm not talking about the plant manager. Of course, you have to have buy-in from him. He has to spend the money, but you need buy-in from the people on the shop floor, right? I've seen it over and over again. The success of an MES relies on the fact that the operator is comfortable using the system and that they like to use the system. Not that they come in every day and say, I can't wait to use the system, but the point is that it's not getting in their way of doing their job, right? And really everybody needs to be involved in this, right? It's not just about the operator or the quality engineer or the supervisor or the plant manager or the process engineer. Everybody has to be involved and make this change. When we've implemented systems like this before, in some cases, what we do is we get everybody a t-shirt when we have the kickoff day, and everybody's involved and everybody's excited about it. And there's a real positive environment and kind of a feeling throughout the implementation and the rollout of the product. It's exciting to see when it comes together with multiple people involved in the factory. And again, back to this data, right? You gotta have good data, right? So can't harp on that enough. It's important to have good data. It's not so much about collecting as much as you can necessarily right away, especially right away, but over time, maybe growing that. But collect the things that are important right up front and get after them and go start your continuous improvement cycles. The ability for people to grasp technology and changes in their business, it's really important to get them used to using the tools that they're going to use. So get them used to the tools as soon as possible. Help them understand what's coming. Help find commonalities between tools they already may know, right? Maybe they use Netflix today. Try to find commonalities between things that they use with the new tools coming in. They can watch Netflix on an iPad. Great, you can use this new software on an iPad too. Look how easy it is, right? Make the data easily accessible. You will be surprised at how much your operators, especially a few solid operators, will come back and actually start to make decisions on their own data and provide you with ideas on how to make better decisions. It's really impressive when you see somebody excited about what they're doing and using the system. Now, going back to sticking with out of the box, don't overcomplicate this. Perfection is the enemy of success, right? You are never going to be perfect. It's never going to happen. You're not going to have a perfect system. You're not going to get 100% of the efficiency that you want to get out of everything. So shoot for a lower percentage there. It doesn't have to be perfect. Sometimes 95% is better than 100% because you're never going to get to 100%. It just doesn't happen. So keep it easy and use out of the box when you can. So let me give you some examples of customers that have actually done this and have seen success, right? So these are real numbers. This is a customer that is in the UK. It's nearly $1 billion company. Probably is if depending on the exchange rate right now. But they make food and they make it's kind of like bouillon, things that go into soup, and they were able to use the system to analyze the entire supply chain that was coming into the product, and actually they were making the product. It was actually weighing more than it needed to, just to make sure they were within the limits that they needed to be within. They were able to reduce product waste by 75% by putting in an MES and implementing the GE Digital solution. And it obviously improved quality as well, but from a product waste, we're talking about overproducing and overfilling is what this 75% mostly came from. But they also improved efficiency by 9%. At the same time they were reducing waste, they were improving efficiency. And this happened really fast. So in one example, they saved 2 grams per unit. Remember I was talking about they were making it slightly bigger than they had to, just to make sure that the weight on the package was what that was written on the package actually was realistic to what was in the package. Well, they saved 2 grams per unit. That is an enormous amount of weight in the particular product they were making. And just in that one product alone, saved $240,000 a year, just in that one product. And they were able to apply this across multiple products. They reduced customer complaints, and they saw another $65K in year in savings across many, many other things, not including the things listed here. So you can see how capturing this data, providing the context like we talked about earlier, and really giving the people, the operators and so forth, things they need to do to troubleshoot and to make decisions on the fly is really powerful, and this is a good example. Another example is a big customer that we work with. This is Procter Gamble, and they were actually an early adopter of digital tools long, long ago. We've been working with Procter Gamble for at least 15 years. They chose a scalable solution, in our case, Plant Applications MES, and it made for teams that, the operating teams, which they have a lot of teamwork going on. Procter Gamble is a fantastic supply chain manager, and the ability to manage their supply chain really comes down to the data that's being provided by the MES system. In some of their plants, they've implemented mobile devices throughout the entire facility. They're able to have operators walking around, have operators walking up to the supervisor with the data, talking to them about what potentially is an issue or a problem or how they can improve the line execution at the time, and really having that data right there in front of them allows operators to make decisions that normally maybe a process engineer had to make before. And then taking this data and bringing it up to the cloud is where they're able to apply the supply chain the value that they bring to supply chain, the ability they have in the supply chain area across their entire enterprise, right? So they're doing great at a plant by plant basis, and now they're able to do it at the enterprise level using all this manufacturing data. They call it their manufacturing system of record when they put the data in our product called Manufacturing Data Cloud. So it supported things that we talked about earlier, but it supported them across the enterprise, right? So now I can do center lining across the entire enterprise. Can I reduce my operating envelope at one facility? Can I apply that same reduction over at another facility? And can I see the differences, and I can see the efficiency that I gained across the entire organization? The ability to comply better with regulations and the ability to archive that data and take it off the system to keep it faster and make the MES perform very quickly was another benefit they gained from all this. So a lot of benefits. This is just touching on the surface of 2 customers that we deal with of the hundreds that use our software. So again, going back to kind of the things that we talked about, and agility and right first time quality is really how they were able to achieve this is through the MES system.
Thanks for watching.